For centuries we thought we knew the sun, a steady, familiar presence in our sky. Scientists expected to simply sharpen the image, to fill in gaps in our understanding. But when the first high-definition data streamed in from space, everything changed. The sun was revealed as a place of unimaginable violence and beauty, where physics is pushed to its limits. Scientists were stunned by what they saw, not a calm, predictable furnace, but a chaotic inferno. Colossal explosions, eruptions of plasma larger than planets, and twisting magnetic fields dominated the view. The sun was alive with ferocious, unpredictable energy. Our star was not just a distant ball of fire, but a complex, dynamic engine-driving phenomena we barely understood. The shock quickly turned to excitement. This was the start of a new era of discovery. Each new image painted a picture of a sun far more intricate and interconnected with the cosmos than we'd ever imagined. The ordinary footage we expected was replaced by a vision of cosmic power, terrifying and awe-inspiring. Humanity had pointed its cameras at the sun, and the sun responded with a universe of wonders and warnings. The familiar yellow orb was just a mask for something far more intense and mysterious. This was a star reborn in our understanding. The journey to truly know our sun had only just begun. For millennia, humanity revered and feared the sun. It was worshipped as a god, the source of all warmth and light, but its brilliance was untouchable. Looking directly at it was forbidden, its power absolute, its glare unbearable. Our ancestors built monuments to its path and told stories of its journey, always from a respectful distance. The sun could nurture or destroy, making it an object of awe and caution. For thousands of years our understanding was limited to indirect observation, its light, its heat, its movement across the sky. Its true face remained hidden, protected by its blinding glare. Then came the age of science and technology. Telescopes and special filters allowed fleeting glimpses, but the sun's intense radiation kept us at bay. The dream of truly seeing the sun up close remained out of reach, until the space age. Robotic emissaries, shielded and resilient, became our eyes, staring unflinchingly at the sun from space. These machines could endure what we could not, transforming our relationship with our star. The fear of looking gave way to anticipation for the wonders these new eyes would reveal. The sun's secrets were finally within our grasp. A new era of solar exploration had begun. To truly understand the sun, we needed to see it with unprecedented clarity. Enter the Solar Dynamics Observatory, or SDO, launched in 2010 to capture constant high-definition images in multiple wavelengths. SDO's mission: to unravel the sun's magnetic field, atmosphere, and the drivers of solar activity that affect Earth. It became our permanent watchtower, gathering torrents of data and revealing the sun's hidden dynamics. Then came the Parker Solar Probe, launched in 2018, destined to fly through the sun's outer atmosphere, the corona. Parker's goal: to sample particles in magnetic fields where the solar wind is born, answering mysteries that puzzled scientists for decades. SDO provides the wide-angle view. Parker dives into the heart of the action. Together, these missions are painting a startling new picture of our star. They are our robotic eyes, staring into the fire, revealing the sun as never before. SDO's images were revolutionary, showing colossal plasma tornadoes, swirling gas, and violent magnetic storms. Solar flares erupted as brilliant flashes, unleashing vast energy in minutes. Coronal mass ejections, enormous bubbles of plasma, blasted into space, threatening satellites and power grids. The sun's surface was a seething cauldron of magnetic activity, with giant loops of plasma arcing high above. Magnetic fields snapped and reconnected in explosive events, driving solar flares and CMEs. Even the quiet sun was alive with evolving magnetic structures and energy flows. SDO revealed a solar ballet of immense power and intricate beauty, a place of perpetual awe-inspiring change. The sun, as seen through SDO's eyes, was anything but calm. In July 2012, the sun unleashed one of the most powerful solar storms ever recorded, a Carrington-class event. A massive coronal mass ejection hurtled through space, missing Earth by just 9 days. Had it struck, power grids could have been crippled, causing blackouts lasting months or years. Our technology-dependent world would have faced chaos. Communications, banking, and supply chains all disrupted. The 2012 event was a stark warning. The sun's fury can threaten our civilization. It highlighted our vulnerability and the urgent need to understand and predict solar storms. Scientists, using data from NASA's stereo probes, learned vital lessons about these extreme events. They refined models to better predict how solar storms travel and impact Earth. The The near-miss galvanized research and underscored the importance of missions like SDO and Parker Solar Probe. We live in the atmosphere of a dynamic, sometimes violent star. The Parker Solar Probe is a mission of audacity, diving into the sun's corona, where temperatures soar millions of degrees. Its heat shield endures the inferno, protecting instruments that sample the solar wind at its source. Parker flies through clouds of solar particles and intense radiation, gathering data never before possible. It discovered the solar wind is structured and dynamic, with rogue plasma waves called switchbacks. These findings offer clues to how the solar wind is energized and accelerated. Parker's measurements are unraveling the mystery of why the corona is so much hotter than the sun's surface. This probe is revolutionizing our understanding of how stars work and influence their planets. Despite our advances, the sun still guards many secrets. The corona's extreme heat, the origins of magnetic portals to Earth, and plasma waves that defy theory remain mysteries. Some observations hint at connections between the sun and the wider galaxy, challenging our models. The sun is not an isolated object. It's part of a vast cosmic web. Each new mission brings answers, but also more questions. The sun's complexity reminds us how much we have yet to learn. The quest to understand our star is far from over. Our sun, once thought simple, is now revealed as a source of endless surprise and complexity. Each new discovery replaces old assumptions with deeper mysteries. The sun is a cosmic laboratory, shaping our world and challenging our understanding. Missions like SDO and Parker Solar Probe show us a star in constant creation and destruction. For every answer, new questions arise. Our exploration has only just begun. Studying the sun is about understanding our place in the universe and the forces that shape life on Earth. As we keep looking deeper, we're not just learning about a star, we're learning about ourselves.